So I'm recording this video to show you how to do a problem like this. On exam 2, I'm going to ask you a problem very similar to this. It'll be in context. So instead of saying event A and event B, it'll have, there'll be some condition here, and you'll have to um, you know, do the same math, it's just in context. Okay. So there's two ways to do this. I don't know if you've watched my video about or looked at the sheet I made about using Venn diagrams. Dr. Stevens doesn't use Venn diagrams. Sometimes people like the pictures rather than doing it straight with formulas. I'm going to show you both. I honestly sometimes, if I'm a little confused, I'll use a Venn diagram. Stay handy. So what you do with a Venn diagram is you have however many events that are happening, you put a circle on it, and in this case, because both event, uh, let's see, how do I get a pointer here? Because both event A and B can happen, I want some overlap. If in this case, so let's answer that very last question I wrote. I mean, are events A and B mutually exclusive? No, they're not, because they can both happen at the same time. If they were mutually exclusive and they couldn't happen at the same time, the Venn diagram would look like this. There's no overlap for the two events or three events or whatever many you have. Okay. Um, um, Truthfully, yeah, I won't say that. I won't say that. I'll make a look at the exam and see if you can figure it out. Um, so to use the Venn diagram for this, well, let's start backwards. I know that this area in the middle, that overlap in the middle, is worth 0.1 or 10% because there's a 10% chance, or the probability of both A and B happen at the same time is 0.1. Now, this event, this here, the probability of event A is 0.6. What that's asking is, what that's telling me is that all of A, that whole oval of A, including the 0.1, is equal to 0.6. So what I've got to do is, in order to figure out, to use a Venn diagram here, I have to, here, let me come back. I have to subtract the 0.1 from the 0.6. So the probability that something's just event A is 0.5. And together they're 0.6. And we'll do that same thing for the probability of B. For B, I'll highlight it again just because I can. For the 0.3, the probability of event B happening is 0.3. Well, that includes the part where that A can happen also. So let's see, got my eraser. So I'm gonna write a 0.2 here. That's 0.1. I don't know what happened. I guess I erased everything. What did I say? 0.5, and this is 0.2 because together they have to add to 0.3. Now, what's the probability of A or B? We'll just add up those three regions: 0.5 plus 0.1 plus 0.2. So the probability of A or B happening. So, or probabilities mean A or B or both. So those add up to 0.8. Now, the next question asks, what's the probability of not point A or B? Well, that's everything else. Looking at the Venn diagram here. Let me go back to my cool little highlighter. Telling me to highlighting today. That's all this region outside those circles, or outside those ovals, I guess they are. So all of that. So the way we would get that mathematically is we'd say, oh, that's going to be 1, because 1 is all the possible events happening, and adds to 1, minus the 0.8 that's inside the circles, or A or B or both. That tells me 0.2, that there's a 20% chance of something not being A or B. Now, the next part, when you see that line, that's that conditional probability Dr. Stevens talks about. And the way you figure out a conditional probability is you're going to do the probability of both events happening, dividing the probability of the thing on the bottom, which in this case is going to be probability of B. So the probability that the both happen is 0.1. Now, all of B. So what we're trying to say is for this one, we're looking for all of B. So the denominator is going to be the 0.3, because it's got to be just B, or the parts just A and B. In fact, the only way we can have a conditional probability of what's probably the A happens given the B happens, well, it's got to be the 0.1 divided by the 0.3. So that's 1/3, or I mean, we could write it as 130, could write it to 0.333, repeating or round it a little bit. Don't round it to 0.3 because that's, I mean, 0.33, I mean, WebDesign would be looking, or MyOpenMath, if you're doing MyOpenMath equations or problems, they'd be looking for some more decimals. And now what's the probability of B given A, or what's the probability that they both happened, or they both happened given that A happened? And what is a 0.6? So that would be 1/6 or 0.16666 or 0.167 would be a good place around that. Okay, so sometimes people get a little confused with these conditional probabilities. So just remember, when you're doing a conditional probability here, you're going to do the probability of both divided by the probability of whatever that second thing is. I mean, if I'm looking probability of I don't know, probability of fast internet, given that the customer is customer consolidated. Can tell where my mind's at right now. We would do, what's the probability that they have fast internet and their customers are consolidated, divided by the probability the consumer is of a consolidated. Okay, so I won't go on anymore about my internet at home. So I hope this helps as far as the Venn diagrams. Now, what if you just don't want to do Venn diagrams? You're saying, Dan, that is just confusing as heck. I don't want to even think about it. What about if I want to just use a formula? Because the formula works really well. It's addition rule, and that's in the textbook, and Dr. Stephen talks about it. And so what you do is the probability of A plus probability of B minus probability of both. So A was 0.6, B was 0.3, and then you're going to subtract off one instance of the 0.1, and that's going to give you the same thing. That'll give you a 0.8, and then you can take it from there. So it's the same thing. So it does work. Sometimes what'll happen, it might happen on this next quiz. I don't remember what I asked you on that. Sometimes I won't tell you the probability of both, but I'll tell you this. So then you're going to do a little bit of algebra, like what if, well, I'll just keep the numbers the same since we know the answer. What if I told you that the probability, what if I told you the probability of both was 0.8, and I didn't tell you this? This is an unknown, right? I don't know that. So what you do is you do 0.8 equals 0.9 minus X, right? The probability of both. We'll subtract 0.9. That would give me negative 0.1 equals negative X. So X would have to be equal to the 0.1 because you divide by the negative 1, right? In case it's been a while since you've done an algebra course. Okay, so that works too. You can do all that with the equation. You can do it with the Venn diagrams too. I think that's it. I think that'll give you what you need. And of course, when it comes time for that exam, you'll see a practice exam question that'll be just like these. And actually, I think I put some in context. So check those out. And we still got a couple weeks before that's going to happen. So don't panic. I just wanted to point you. This is a question that about half people will not get all the points in this question. It's historically what happened. So maybe you folks will break that and do better. Okay. And please, if you need some help, come see me. Grab a Zoom time. And if my times don't work, we can probably work something else out. Okay, I'm going to stop this video.